In this video, we're going to learn how to use T-charts to explain periodic trends. So, first question, which has a higher ionization energy, nitrogen or phosphorus? Ionization energy, you may recall, is the energy required to remove an electron from an atom. If an atom has a very high ionization energy, then it is holding its outermost electron very tightly, and it requires a lot of energy to remove that electron. If it has a low ionization energy, then it just means that the electron is removed very easily, that it is not held very tightly by the nucleus. So in order to make this comparison, what we can do is make a T-chart, which looks like this. We have on one side, we have nitrogen, and on the other side, we have phosphorus. And what we will first do is we will compare the number of energy levels, N. And what I find is that for nitrogen, nitrogen has 2 shells, it's in the second period, and phosphorus has 3 shells. So our T-chart in this case is very simple because we've already seen a difference in the shell number. What we can conclude is that phosphorus having electrons in a higher energy level, those electrons are easier to remove. That will make it have a lower ionization energy. Nitrogen, the electrons are held more tightly, they're closer together, they're closer to the nucleus, and nitrogen will have a higher ionization energy. So the explanation could be something to the effect of N because its valence electrons are held in a lower energy level than P's, making them harder to remove. Move this over a little bit. Next comparison to make. Here we go. Next comparison to make is nitrogen versus fluorine. So in this case, we'll make a T-chart again, but what we will find is that the energy level of the outermost electrons in nitrogen, that's energy level 2. Phosphorus, it should be fluorine. There we go. For phosphorus, the energy level is also 2. So here we can't make a distinction based on the energy level, but we can based on the number of protons. You may recall that as you go across a period, the attraction of the valence electrons to the nucleus increases as you're going to the right, and that's because the nucleus has more protons. So nitrogen has 7 protons, fluorine has 9, and what we find is that those 9 protons attracting electrons in the second shell are better at doing that than 7 protons also attracting electrons in the same shell. So what we can say is that, if I can move this, let's see. Fluorine has a higher ionization energy because its valence electrons are its valence electrons, which are in the same energy level, I'm abbreviating as N, as nitrogens, are more strongly held by its nucleus, which has more protons. And that's indicated in this T-chart right here. So our final comparison is going to be between nitrogen and the nitrogen 3- anion. So in this case, we have N and N3-, and on this comparison, our N level is the same. Yes, nitrogen and N3- have electrons in the second shell. Our number of protons is also 7 in both cases. So the difference actually is the number of electrons, which, while nitrogen has 7 and the N3 minus anion has 10. Sorry, I just realized we're kind of running into my video here. But what I'm trying to say here is that the difference is the number of electrons. Nitrogen has 7, N3 minus has 3 more than 7, it has 10. And so that's where we can make the distinction. So if we were answering this question, writing out a response, we could say nitrogen has a higher ionization energy. And the reason for that is because although it has the same number of protons and energy, well, let's say n levels, as N3 minus, and I'm sorry about that showing up is as it is. I'll actually just write it because I can't leave it as is. Because it has the same number of protons and n levels as N3 minus, it has less electron to electron repulsion than N, I'll say the N anion, meaning N3 minus. So what I'm saying here is that when you add 3 more electrons to nitrogen and make it N3 minus, those electrons will be repelling each other, and that makes them be of relatively higher energy and makes it easier to remove an electron. Therefore, nitrogen with no extra electrons will have the higher ionization energy because it's harder to remove an electron from it. I've only focused on ionization energy here, but you can make pretty much the same type of argument for electronegativity or atomic radius. Just understand that ultimately everything has to do with the attraction between the nucleus and the valence electrons. And you just need to make the same T-chart in every case. It's just a question of, are we talking about is there a difference in the energy level, or is the difference found in the number of protons or the number of electrons? I hope this has helped. Let me know if you have any feedback in the comments section. Thank you.